everybody, and warm welcome to our next episode, FibreCraft Insights, Unveiling the Strength of GFRP. Let's take a quick recap. We introduced this very innovative material. We discussed about the temporary properties. We discussed about the long-term applications. And today it's a time where we actually want to discuss the product forms of this innovative material, how those could be used in the infrastructure projects. So let's get started. Once again, let's welcome Mr. Pierre Hofmann, our knowledge partner for this series. Pierre, let me start with the tunneling application, because I see as far as the Indian infrastructure industry is concerned, tunneling projects are really at a peak. And when we say tunneling projects, we have two kinds of projects. So maybe we can start with the TBM tunneling, which is majorly used for the metro projects, along with the urban rail and several more than 18-20 metro projects happening right now. So how do you see, how do GFRP can add value to these kind of applications?
Of course. So indeed, FRP has been used for many years in TBM work, and that's true, that's primarily urban rail. Of course, the very first application, which is actually innovation from Dextra at the late 90s in Bangkok, and then later introduced in India, is the soft tie application. So the idea here is during the construction of line by TBM, the TBM has to go through several concrete walls. I mean, a retaining wall. They can be diaphragm wall, they can be board pile, and that's true for the launching shaft, retrieval shaft, also through the station. So all those walls that are reinforced concrete, the rebar in the alignment of the tunnel need to be made of GFRP to ensure easy penetration of the tunnel boring machine through the concrete without damaging the cutters. So this is very common. I mean, I repeat, we've been doing this extensively in Asia, and today we're very proud to see this technology used all around the world in any TBM project. Maybe one thing to mention is the TBMs are getting bigger and bigger in diameter. So not only for rail, but more and more for highway project, large TBM 10, 12 meter, and therefore the loads applied to the system are getting increasing, and so that's why we have very high challenges in addressing those high mounts. On top of that, GFRP can also be used also in the face in the tunnel going through a fault zone. So we have GFRP pipes that can be installed from the manhole covers or from the inside of the TBM to do a localized reinforcement of the ground through injection to ensure the stability and the continuous progress of the TBM through the fault zone. All these are temporary application. What's really exciting is now we are working on implementing GFRP bars as a reinforcement of the segment of the TBM. So now we are reinforcing the lining, the precast concrete lining, and that allows much better design. We can do better corrosion resistance. We can reduce the thickness of the segments. And so that's allow us to design the permanent structure of the tunnel in a much better way.
Oh, fantastic. I mean, to some extent, as you said, soft tie was there. People were aware about this, but the other applications of the GFRP rebar is something really very new and will have a lot of technical value addition. So another popular form of tunneling is NATM method, popularly called as an atom, especially in the remote areas. Of course, again, depending upon the ground condition. So how do you see GFRP would be a good replacement for steel there?
Yeah, of course. And I would say likewise, GFRP has been used in the conventional NATM, SCM, or mine tunnel for many years. I would say probably even before being used in TBM tunnel. Why? Because the traditional way is to do what we call face bolting. So again, it's in the face of the tunnel, in the alignment of the tunnel. And here we are using the GFRP as a rock bolt in this case, but for its cuttability, easiness of destruction. And that's a very well-known application also in the mining application. That's why mine tunnel share the same technique as mining. Very well-known and being done for many years. I would say equally what's exciting again in this kind of tunnels is the possibility to divert the GFRP application from the face, which is temporary, to now the radial support. So the lining of the soft ties, of the tunnel. And so in this case, we installed the rock bolt, we can install them in the part of the lining of the tunnel. So typically we would replace the temporary steel rock bolt by permanent GFRP rock bolt, and that allows us to design much more effective support, and through the reduction of the concrete lining. So it's possible to change from cast in situ to, for example, sprayed lining, and it's also possible to reduce the thickness because the rock bolt takes some of the load. So something very disruptive that allows to speed up construction and also reduce the quantity of material, and of course, combination of the two, reduce the cost of the construction of the tunnel.
I think indeed, really, you made a very valid point. This is going to be a disruptive change because conventionally for so many years, we are used to use these steel bolts and we know GFRP only for the face bolting. But now, as you're saying, the uses of GFRP as a primary load taking member is going to be a significant change, not just technically, but also bringing a lot of commercial value to our customer. So I think with this, Pierre, let's take a pause here. But definitely we want to know more about you, maybe from anchoring point of view. So maybe next episode, we'll discuss more about the active anchoring and passive anchoring for all kind of slope stabilization projects or underground metro station projects, all those the application we'll see. So meanwhile, all our enthusiastic audience, we are really happy that we are getting a very good response. We are getting a calls from you, messages to include some specific queries. We'll definitely try to include those in our subsequent episodes. So please keep interacting with us. That gives us a lot of confidence. Thank you very much. Thank you, Pierre, once again. And let's meet in the next episode. Bye-bye. Good day.